Hi, everyone. Welcome to the 11th session of the virtual event Exploring Bejo's World. Today we have a very exciting session with pixel farming robotics. We are very happy that they are giving a presentation on this virtual event because they are a company that is building a very ambitious and interesting multifunctional agricultural robot. And also because it's such a functional robot, it really may also redefine the way we look at agriculture and how we configure our plots. So we are very happy that they are coming to join us for this presentation. And was er niks te horen? Of?
Ja, dat is niks.
Oh, sorry, I was apparently muted for a few seconds. So we are very glad to invite Cindy and Arend to come forward and to start the presentation. Please notice that all the questions are open. The chat is open for questions, and we will find a moment to answer them. Welcome, Cindy. Please go ahead, and you have the floor.
Thank you very much. I wish everybody a very warm welcome to the greenhouse of pixel farming robotics here in Almkerk. I'm here with two of my colleagues, actually the two men in black you see in the picture right now. So Kees is the one who's holding the camera. Arend is a founder of Pixel Farming and CEO from Pixel Farming Robotics. He will tell you everything about farming with a robot and the possibilities, showing how our robot looks like. Please feel free to put your questions in the chat. If there are a lot of the same questions, I will collect them and ask them live to Arend. In that way, we can have a nice session together. And so Arend, the stage is yours, actually. Good luck.
Oh, thank you, Cindy. I'm Arend Koekoek, and my name is in letters on the screen, what I see now. Do you see me? So the cameraman is Kees, and he will share me in front of the presentation screen. So meanwhile he's doing that, I'm going to talk a little bit about what I'm going to tell you today. So I'm not gonna go into technical difficult
Arend,
things.
we can't see you yet. So Kees,
you have to.
Kees has to open his camera. He will be broadcasting you, right?
Yeah, it should be. So he's in.
Kees is both muted and his camera is off.
Yeah.
Okay, great. Now we hear.
So.
And Cindy, please also mute your camera, or not close your camera. Yeah. Dan moet je aan. Arend, you still have to be unmuted. Or Kees has. We don't have your sound yet.
Muted?
Yeah. Now we hear you.
All right. Let's try this again. My apologies to the international stage. So I'm going to tell you a little bit about what happens when you have a robot on the farm. We feel that farmers do things to ensure food security. They have some problems on the farm, like soil depletion, soil densification, which cause limitation of water storing capacity, and all the problems that come with that due to things like climate change, which we all know a little bit about, We have the problems with the dependence on permitted chemical agents, which are getting limited every year. So that's an issue. Now, there are solutions available, but they usually require a lot of manual labor. As you can see here, that with our co-European people bound to a bed. So we researched, what do the farmers want? Well, they want control over the weeds, preferably without chemicals. They want to have a reduction of manual labor. They want a high yield. They want a healthy soil. So what we've come up with is a solution to do that, which is called pixel farming. And what I'm going to talk to you about now is the part of pixel farming in which we use robots to reduce the manual labor required to do so. So this is an example of a project we're doing with industrial growers in the Netherlands now, with green beans. It's a production field. What they ask is, can you hoe these beans? So keep the soil brown, basically, while the beans are growing, so we don't have the weeds. Now this is and we want to do it with an autonomous robot. Now we can do this. You see down here, this is robot 1 with hose as a tool. As you can see down here, it has GPS RTK double to provide straight driving. It has solar panels on the top so that it can drive a full working day without having to be recharged. It's tested in soils, sandy soils, and clay type soils to ensure proper production. And what the funny part is, when you see these people working with Robot 1, you see a cluster of people checking that the machine does what it needs to do. So really they're about controlling the machine in a similar way as you do with a tractor, fully focused on the machine to see what it does. So they're looking at whether or not it's hoeing properly, the hose up properly besides the machine. But then there's this cluster of other people who trust the robot and who are looking at the plants, and they are deciding, is it necessary to do the hoeing? Maybe there are other ways to take care of my plants to keep the soil healthy. For example, by keeping an undercrop, and instead of hoeing it down, maybe mowing it down using a streamer in this case, to cut down the plant to the level where it needs to be, to not take nutrients, not take light. That's a different way of working, of thinking about what a robot needs to do. So what happens on farm? What do you need to do to get the machine to do what you want? Well, in the first thing, you need to tell it where to work. You need to have a patch of land addressed. So there you need to work. And also you need to tell it how to drive these lanes. So in the system do it. Then you need to explain to it what type is the crop actually, and how is the crop seeded on the plot. Maybe tell it a little bit about what plant combinations are okay to have there and what plants are not okay down there. Then you might want to check to see whether or not the right plants are at the right location on the field. And now here already you see a little bit about pixels, and I'm not going to go into detail about what this does. You can check in with the insider sessions in December if you want to know more. But what the system can do is it can support you with good and bad combination advice, which is actually what the robot might need to do the right thing at the right location. So you can do now. What you might need to do is you might need to check whether or not the robot will actually understand what the plant is, because this robot is it has 10 cameras to inspect the soil that it's driving across. But of course, the photos they're nice to have, but really not the things you want on the farm. What you want to check is actually the plants. Now, the first thing to understand is, does the machine know what it needs to take care of? Does the AI model in the machine detect whether or not the green bean is detected? Because in this case, it's 91% sure that this is a green bean, but it missed some things. Another thing you might want to do is you might want to explain it how the plant should grow. So what it can expect during the next coming season on what it will grow like. And then again, you might want to validate using drone images or using images that the robot has acquired, whether or not it's going according to plan. So that's typically something you might want to do. And of course, you might want to validate all these settings in winter. And we have this digital twin connected to the robot where you can actually simulate the way your settings work in a similar way as you would do with your tractor. When you're engineering in wintertime, you're servicing it. This is the way you can service an AI on a robot as versatile as the Robot One is. So what you see down here, for example, is that it's validating whether or not it can get the data from the server, and whether or not the streamers in this case cut down the grass properly on the field. Maybe not in this case. So what does it mean? Let's get some practical action. This is an example of a tool which is used to create holes as a planting pattern. And of course, this is a demo which we done down here on the campus Innovation Center to demonstrate this to you for today. So what you see down here is a tool which drills down holes into the soil at very specific, very precise location. So this is programmed using the tools you saw, and then this program was sent to the robot. The robot then does this handling with this gripper tool, actually, which is then used now to drill holes into the soil. And then what you will see later is that it will a colleague of ours will put down the plants, and then the mowing devices that you see down there, the streamers, they will go around the plants to remove the weeds. Of course, this is a demonstration. There are no weeds grown yet, but this gives you a rough idea of what a versatile machine like Robot One can do for you. So it sees the plant, it moves around the head around it, and this way we have a form of so mowing between the crops, that way managing any weeds that would be down there inside it. Now this is an example where we have streamer heads. Of course, this could be hose, or this could be basically any type of mill is also a feasible tool. But that way you can control anything in the field. And what you saw is also the pattern, which is quite wide compared to a normal production field. This is all programmable. You basically just set it up in the way you want it processed, and the robot will simply execute it. So let's take a look at the machine itself. We have two of them down here for today. This is Cindy, the colleague. So these are the machines. What you see down here, you see the cameras. These are actually LiDAR, 2D LiDAR cameras. So they keep an eye on everybody who is walking around the machine to make sure it's safe to work with the machine. There's a lot of safety buttons down here to make sure that you don't do when it's doing something stupid, that you can basically just tell it to stop. Now what you can see, so you see more cameras down here, and what you see down here are actually toolbars with cameras inside. So there's 3 of them on this side, 3 of them on the other side. These ones, when we're driving in this direction, these ones you would use to plan the action and to make sure that the time, what you saw down here in the video earlier, this bar will detect where the plants are and steer the tools. And the other one bar is used to verify that what you try to do, that it's actually done in the right way. And that way you have a quality way of working with your soil, with your crops. Now, if you would go down, now maybe first in case we can go on this machine. Down here you see the tool sets, which are in this case the streamer tools. It can move in all kinds of directions. It has an execution speed of 1 meter per second. So it can basically move these heads at the same speed that it can drive. That way, making sure that you can do basically all operations at an hectare per hour processing speed, which should provide you with a financially viable working solution when you work with this machine. So that's roughly what you see down here. It has 10 arms each. Each arm can carry up to 100 kilograms of tool load. So and altogether you could potentially load 1 ton of equipment to work with it. Each tool can provide roughly 2 kilowatts of power. It should be way enough to do the most difficult things with what you wanna do. So yeah, another thing is if 1 hectare per hour is not enough for you, you can drive 2. So one person can actually, using one control, can steer both machines. Actually, if you want more speed, you can drive 5 of these machines in parallel, and that way have a working width of roughly 15 meters. So you could process 15 hectares per hour, 5 hectares per hour using these machines at 1 millimeter precision. So giving you way enough processing capacity to work in a fast way using this type of machine. For the tools, you see, you saw a gripper tool, which is, I'm looking for the one that's down here. We've mounted it, I think, at one. It's down there. You could actually use that tool for different solutions. You could grip things, get things pulled out of the ground, but you could also use it to plant, and there's an example down there. Sorry for the quick motion, but this is an example of what we call a pixel. It's quite common in the Netherlands to get your pre-breeding plants in this way. It can grip it, put it in the soil that way. Now the one you saw down in the video is the first edition of the arm. It can move at 1 meter per second, but as you can see down here, this is a prototype of a new tool that can be mounted underneath the machine. It will come out in the official one in February, which can process roughly 10 times faster, and that way make really fast motions on the soil to get planting. And you see the crate down there, it can actually pick plants from the crate, put it in the soil, and that way do very precise planting with GPS registration. We are at 1 millimeter accuracy in planting. So this machine can actually provide you with planting capacity at very high resolution detection to your system. Yeah, I'll take them. It's
Adam, please repeat the question of Cindy
Yeah.
for everybody to hear it, and then
Yeah,
then
sorry.
answer it, because we
So
couldn't
the
hear
question
Cindy.
was, how difficult is it to change the tools from weeding to mowing? It's a matter of removing 4 bolts. So the changing would take, what do you think, half an hour, max half an hour, 15 minutes. Yeah, you can. So basically, that's one of the things you can do. Is that, I hope this answers your question, the person who wants this. It's not required, by the way, to have one type of tool on a machine. You can easily have, for example, 1 row of mowing heads and 1 row of hoeing heads. That way, and you saw it. Maybe you saw it in the video earlier, where we had this gripper tool and the mowing tool on one machine addressed. So, are there more questions? Yeah, there are.
There's another question. Do we also have arms which can work in certain orientations? For example, to spray crops under a certain angle?
Yeah, that's a funny thing. What you see down there with the arm example down here, it's mounted horizontally. There's really no reason why not to mount it on a different way. You see the mounting plate down here. There's the mounting holes down here. you see this block. Currently, it's positioned like this. You could also position it like in an angle. But what you can, and then what happens is that you can actually change the location where you spray or change the angle. So that's not a very difficult thing to do. You could do that. What we provide is the basic platform. We provide the Lego blocks, as you will, to change it. You get all the schematics, you get all the engineering stuff to make your own implementation. We can provide you with standard solutions to get going. And maybe I'll talk a little bit more about the way we support your engineering process when you want to get this on the road.
Does it operate in all weather?
Yes, it does operate in. No, I'm lying. It doesn't work on Antarctica. It's not prepared for ice. But it can, when you're thinking about slopes, we've tested it on slopes until roughly 37 degrees. So there's with this version, there's a limitation down there. So when you're in very hilly conditions, you have to be. Yeah, we didn't test it. Let's be honest. We have a support program to help you with that, but there's limits on slopes to where we've been testing. Yeah, I hope this answers your questions. Let's go back. You're not the first who asked these questions once you want to implement this type of machine on your farm. This is one of the things we've seen the last couple of years. How do we help you with getting such a machine running on your farm? Well, there's one of the things you need to learn, for example, or people need to learn to operate this thing, is how do you get the data in the machine? How do you get your machine to drive? One of the things we found is that you need to be able to fly a drone. It's not that difficult, but you typically need to operate it, which means you need to get the drone flying license. Now, when you're driving a robot like Robot One, it's a very similar way of working. We hope it's not flying, but you need similar types of skills to do this. Also, you need to be a little bit handy with the computer to upload images and to tell the machine what the plants are and what the crops are. Again, there's a lot of tools there, but if you really don't understand what a keyboard is, that's a problem when you want to use this technology. Of course, we have support partners to help you with this, but in general, it is an issue. Now, this is the video about from our home base, Campus Innovation Center in Almkerk, where we have all the engineers and all the support guys to help you with the problems you face when you're engineering a tool or when you're testing a certain crop combination, or so to get this handling done, because we see that's an issue. Also, we have a network of universities and knowledge partners to help you address the growing issues. So not just the technological issues, but also the biological issues on what happens when you start thinking about using an undercrop with your cropping. What type do you need? What happens in the soil? How do you feed the soil? Of course, we from robotics, we don't have all this knowledge. This is one of the reasons why we really love to work together with Bejo, who has a lot of this knowledge available in their labs, in their knowledge centers. So we work with these types of partners to get a digital model of the plants, to get a projection available into this simulation environment to help you prepare for next season and to help you to understand what tools you might need to get your crop prepared. So this is actually one of the things we're doing down here at the campus. When you're thinking about what does it cost, this machine, you might wonder, this machine costs roughly 185,000 euros to get going. There's an onboarding program available. There's a lot of public support available to get you on the road. If you want to know more, sign up for one of the insider sessions in December, where we can talk more deeply with you in detail about the the thing you want to do. If you have a lot of knowledge about certain types of crops, we're very interested in working with you on getting this knowledge into AI and on the field with our robot. I hope this helps you a little bit and gives you some idea of what you can do with Robot One. My name is Arend Koekoek from Pixel Farming Robotics, and I thank you for your attention. Are there questions, by the way, still? Cindy, are there more questions, or am I just...
No, the questions are answered actually, and I see many hands of applause coming down. So
Cool.
this was our presentations. If you have any questions left about a specific crop, about your project, about using Robot One on your farm, this is the moment. And
Yeah, I'm not going anywhere now, but I really thought that this was enough to send frontally to you to understand. But of course, I really love to talk further with you in detail about certain issues. So if you want to know more about, or you want to see certain things, we have a cameraman available holding the hands, so I can tell you all about it. So feel free to ask the questions, and I will help you. If not, you can always come back later and reach out to Cindy, I think,
yeah.
to schedule a session.
Can weeds be burned? There comes another question. Can weeds be burned?
Ah, that's a very nice question. We've been testing with laser since 2017, I think, case it was, in all types of power. We're currently testing with solid state lasers in the higher power ranges, and yes, you can burn weeds. You can cook water in soil. So there's multiple ways to get rid of the weeds using burning technology. So we're working with that. There's problems when you do it with gas burners. We've also been testing with that. We've been testing with hot air burners, both wide nozzles and very small nozzles. But the problem with that types of gas burners is that the gases go somewhere. So they burn when they're close to your crop. They burn your crop. With laser, we don't have this issue. It's just a matter of power. So we're now scaling up the power ranges. We have been initially we were testing with 5-watt lasers. We're now stepped up to 50-watt lasers, and we're gonna step up next year to 500-watt lasers. And we can mount this machine with 10 of these 500-watt lasers. So I think it can fly to Mars with this type of power. Hope this answers your question.
Another question is there already a specific operation in a certain crop that the robot can perform? I guess the green bean example.
Yeah, for example, we're testing with multiple crops. In fact, you see the fields down here with all types of crops we're testing with. But we have in the production fields been testing with green beans. We've been testing with carrots, which is difficult. We're currently going to test with spinach next year. We're going to start with the onboarding program. There's people who are going to do onions. There's people who are doing herbs. There's sugar beets in the program. So there's yeah, that's the funny part. The funny thing of using a versatile machine is that it's quite a nice clean cut on where the machine ends and where the crop starts. So that's working quite well.
Solar panel provides enough power full day in a cloudy and a rainy day.
What a good question. Of course, it's not just solar that is running on. There's battery, so a lithium battery pack installed in the machine. So in a rainy season, you need to run on the batteries. and as soon as there is a little bit of sunshine, it will recharge it. But on a cloudy, rainy day, you will drive on the battery pack with the current charge, with the power pack that's installed in these machines that are down there. They can run one full working day on a single charge, and then there's the wireless charging station we have. So we have an induction charging plate which they can drive to recharge themselves on a very rainy day. Although you can debate on whether or not a robot doing hoeing things or doing things in the soil, whether they should be outside on a rainy day, because I think they ruin more than they help. But on a sunny day, which is normally the days that you work with weeding operations, then it can run all day and even end up with a more charged battery pack at the end of the day than it went onto the field. So it could, in theory, operate past sundown. So we don't recommend it, but it can be done. It's not legal to do this in Europe, but you can technically do this. So I hope this answers your question. Is it easy to move from the farm to the field? There's two ways to move from the farm to the field. You could drive it. It has a follow me mode, so it will just follow you like a drone would. But you would only do this when it's close to you. Normally we put it on a transporter. We have a transporter for behind a normal car or behind a simple tractor. Then it's quite easy to do it like that. That's the way we do it with projects now. But if you have a bigger installation, you would have a deep loader behind a truck, and you take 3 of these machines, and you would have the battery back or the battery recharging station on the truck, and you would also have the control room on the truck, and then operate the machines from there. That way, keeping sidelines, visual sidelines with the machines while they are doing the work on the field.
Do you think you will develop robots for cereals?
I'm sure, but I think I don't grow the cereals. I think you will. But you could you could use this machine, or I think you might use a robot 2 to do this. It's the next generation of this machine, because there's a limit with this machine you saw down here. It has a working height or it's above the crop, which is limited to say 70 centimeters, which I don't think is enough, or at least we've seen with the testing with cereals that we did, is that it's a bit on the low side for cereals. So it would not be the initial crop to use this machine, but you could do it in the early stages, and that way keep the soil clean. Yeah, we would recommend to use an on-the-crop in that situation. Yeah. How do we use this machine in carrots? Well, basically what we do is we seed the carrots into small rows instead of just on a wild configuration, where normally with carrots you have this wild configuration. We put them in straight lines, which is an option for certain seeders, and then we use the laser to go between these crops. It's still under development to do this, so we're still validating the results. We have, I must say, we have quite nice production result this year on a very small strip, but a lot of other issues with the other management weeds, because you need to use a combination of tractor borne how do you call them? Yeah, aanaders. I don't know what it is in English. There's
Ridgers.
Ridgers. Yeah, exactly. So you need a combination of tools, and we didn't have them on the campus down here, which limited our research project. But I think within 2 years this will be done by somebody who understands this and is supported by us to get the tools running. This is actually one of the reasons why we have the laser project, because we expect this tool to be the most successful in that setting.
Okay, what about accuracy during wet and dry season? And does it have a tool to give fertilizer / feeding to the crop?
Yeah. So the wet season, the dry wet season parts, the limitations are really on the type of tires that you're using, or the wheel sizes that you're using, and on the way you prepare the fields. So it needs to be able, particularly in the wet season, it needs to be able to not go through the top layer where it's driving across. So the way we are testing now is with an undercrop of clover with grass, where it's driving across to keep some driving bed, and then it can drive quite a long time. In fact, we're still driving down here in Almkerk, as you can see, which is a very wet area. We're at sea level in the Netherlands, and we're still having a proper a layer where we can drive across. So that part that works. The other part has to do with feeding the plants, or using fertilizers as an example. There's a project now running of somebody who's attaching a hoe to the heads, and that way using the head as a distribution of fluids actually, and that works. And you can use these tool carriers. You can use them to add canisters of a certain mix to feed the plants. So that's there are guys trying to do this. I hope this answers your question. If you want to know more about this, talk in detail, reach out, book an insider session, and we can go into detail on your particular situation, on whether or not we can do this. So.
Okay, so I have shared some web pages from us, and I just shared my email address. So if you want more information, just reach out to us. I think we have come to the end of our presentation. Rens, can I give the stage back to you?
Yeah, absolutely. Thanks a lot, Arend and Cindy. That was a really nice and impressive presentation. I really hope that in the near future, within 5 years, we see your robot working on different farms, performing different operations in the same day. I think that this year really has learned us that labor in agriculture is becoming a more and more pressing issue. Some jobs people cannot find enough people. Some operations people don't want to do at all anymore. So I really think there's a huge gap, and we hope that this beautiful Dutch robotic company can be one of the leaders in robotization in agriculture. Then for all the other people who joined in, please notice that in half an hour at 15:45 there is another presentation from Farwise, who is doing weeding operations and creating lots of data with their AI thing. So please also join in, and it's especially interesting for row crop farmers. There's one question from Julie Leglise still, Arend. How much area it can do in 1 hour?
1 hectare. So it can do 1 hectare per hour on a normal operation.
Okay, thanks. So with that question being answered, I think we've come really to the end of this session. Thank you all, and please join in at 15:45.
Right.
Have a
Thank you
very
very
good
much.
day. Thanks a lot, Aaron. Thanks a lot, Cindy.
Bye-bye.
Bye-bye.